How's it going, everybody? Maxim here. I'm the founder of Woven Analytics and Woven AI. Today, I'm going to be holding our first live chat. We'll also be recording this so you can watch it after the fact. You may hear some dogs in the background. There's nothing I can do about that. They usually like to bother me when I'm on a video conference, so we'll just bear with it. Today, we're going to be going over how we grab data from 500 Farm, how we ingest that data, and all the processing and analysis we do to present it to you in a way that makes the app performant and makes it useful to you. So first, we'll start just with a diagram here, and I'll just zoom in a little bit. And first thing that we do is we grab the offers JSON and machines JSON from 500 Farm. The links are right here. I'm not going to show them to you. You can go see them yourself. Second thing we do is we ingest that data, so we deserialize it from JSON to Java objects. Our entire framework runs on Spring Framework, which is enterprise Java. Once that data is deserialized and loaded into memory, we can work with it much more efficiently. So the very first thing we do is we update what offers are rented. Vast obfuscates what's actually rented. They just tell us what's not rentable, and we have to use utilization and other techniques to calculate that. So what we basically do is we use the difference between the last sample 2.5 minutes ago and current sample of a machine's utilizations and offers rentable states to determine what's actually rented. And I'll be showing you that in a little bit more detail later. And we also maintain offer prices using Vast's price lock rules once rented. Once we have the JSON deserialized and analyzed, the first level of detail, meaning we know what's rented, we can now start figuring out utilization. So the very first thing we do is these all happen in parallel. So we analyze GPU utilization, machine utilization, machine deltas, price efficiency, correlations of hardware metrics to prices. Let me scroll down a bit. And listing context, basically your auto sort position. So let's take a quick look to see what each of those are. So for GPU utilization, when you're in the offers section of our website, everything here comes from the GPU utilization tables, okay? And I'm gonna show you exactly what those tables look like in a minute. I just wanna start just with a little bit of a high-level diagram to show you our ETL and analysis, where it's used on the website, and then we'll literally get into like observable standard out and the code that runs all of this. So for the utilization that we just talked about, GPU utilization, that's everything here. One reason we create summary tables is because the raw offers data and JSON data, there's just too much of it. Like every cycle, every 2.5 minutes, we store 24,000 offers. So you could not possibly do a full history quickly. Like for instance, I'm just gonna pull out to say 90 days. That's 90 days of history. Let's pull out to a year. That's a year of history. And let's go back to 2 years of history. So to be able to access all sorts of metrics that far back and that quickly, you could not possibly do that just with the offers themselves. We can only do that with summary tables. And that's what each of those analyzers are. So again, for GPU utilization, that's everything on the offer screen. Machine utilization is everything in machines. Remember that machines all have a number of offers within them. So a machine's utilization is based on the number of offers that are currently rented. So this actually shows us at the machine level the different metrics, and that's the data that's pulled there. For machine deltas, that's where we actually look at the verified states for any type of GPU. And we actually, the minute a machine shows up on Vast, we start tracking it so we know how long it's taken for it to get verified. And then we have the offer price correlation. So we basically, this feature isn't used as much as I would expect it to be used, but we basically say for any GPU, any number of those GPUs in a chassis, the verification state, the number of cores, the RAM, disk space, disk speed, and the inet up and down, we can tell you what the prices are, 10th, 90th, and median for every one of those metrics, and it's that metric over history. So needless to say, that's what the offer price correlations are, and listing contexts is over here in performance. So remember how I said that you can't just look at offers raw? Well, we can. First of all, you might be able to if you indexed every single metric that you wanted to search on, but the problem with that is our offers data and machines data is probably 80% of our 14 terabyte database, so we could never really do that. But we do index it by machine ID. So in places like here, where we show the actual offer history for a specific machine, we can show its utilization. This is the machine metric price correlations. This is where our price compared to other machines just like ours in all of our different categories within about 10 to 15%. So basically this is showing what the prices are 10th, median, and 90th for each of our hardware categories for a specific type of a machine. But needless to say, that's where we use that price efficiency and, I didn't show you the listing context. So as part of this history, we also show the score, DL perf, and also the auto sort position. So I was not rented during this period. So we actually capture our auto sort position at every one of those unrented periods. An analysis that we've got coming down the road, which will show how important auto sort is for certain levels of utilization and certain prices and how you get the highest possible utilization and revenue from auto sort position. But that's coming down the pipe later. Needless to say, let's go back. So that's what each of those analyzers do, okay? So we basically, let's just quickly go over it again. We grab the JSON from 500 farm, we deserialize it, we figure out what offers are actually rented, and we do this every 2.5 minutes. We then, all in parallel, figure out GPU utilization, machine utilization, the deltas for every specific machine to figure out what's actually been verified or not, the price efficiencies between every machine and like machines for all those key hardware metrics, the offer price correlations, so every rented offer for every one of those hardware categories for every machine on Vast, and the listing context specifically around auto sort position. All right, cool. So now let me show you what this actually looks like running. So what we have here is, let's just start right here. So basically we start, whoops, this will stop in a second. But needless to say, I said needless to say a bunch of times today. So we start at ingesting the 500 farm data, offers, and machines. We then run the rented offer algorithm. Now that we don't need to change any of the machines data, meaning what's rented or not, because that's in offers, we save that data. We then, that's the rented offer algorithm coming back. We then do the auto sort analysis or the listing context, that's right there. We then start the GPU analyzer, regional GPU analyzer, the machine deltas, price efficiencies, and here's all of them returning. And basically so that happens every 2.5 minutes. And here we are saving the offers. So just to show you, every cycle, we analyze 24,000 offers, 5,000 machines, and 3,300 listing contexts. So that's how many machines are actually vacant at that time. So a full cycle takes about 2 minutes and 10 seconds, and then we sleep for another 20 seconds to maintain that 2.5 minute interval between samples. We store every 5 minutes. Okay, so that's that level of detail. So now let's go to the really painful level of detail, if you're into that kind of thing, and I will show you how everything works. So we're gonna first start with 500 farm ingest and deserialization. So we kick off something called the ETL service. The ETL service grabs the 500 farm data and it creates our entities. Once that's done, it calls analyze, and the analysis service starts. Let's just go down here. So the very first thing we do is when we call analyze is, hey, if this is the first time we've been running, we need the previous sample of data. So that's where we pull it from either local or from a master. And now we have last sample, and current sample is everything. Hi, Mika, how are you? And we have current sample from the data that we got from 500 farm. So first we have to set up our cache and our current data. Once that's done, we can actually save our machine's JSON to memory. And let me show you what that looks like. So the machine's data, when we store that, we store for every machine ID. We extract certain variables that we want to index, but we also store the original JSON. So I'll show you what that looks like. And there it is. And there's the original JSON. And all that original JSON is right here in the performance section. That same original JSON for every sample is right there. Okay, so so that is the machine's data that we just saved. So let's keep going. We then run our rented offer analyzer. The rented offer analyzer, we're going to go into a little bit of detail there. So this is where we instantiate it, and we choose the version that we want to run. So the first thing we do is we grab the offers for the specific machine we're going to analyze from the last sample, and then we grab the current sample and we run update rented offers. So let me walk you through our rented offer algorithm. All right, so the very first thing we do is we first need to make sure that your utilization is greater than 0. If it is, then we first we determine, hey, because in our differentiation calculation, we say, hey, from last sample to current sample, the difference from a 4 by being rented 2 offers and then 4 offers is usually a 2 offer size rental. So that's what we do in the diff. The first thing, though, is we check if it's an odd number. If it's an odd number, then we use our version 1 algorithm, which counts using utilization and unrentable offers. So it deobfuscates that way. So it starts filling offers from unrentable offers from min GPU. So if you have a 8 GPU server and you just went from 0 to 100% utilization and your min GPU is 1, it's going to fill it with 8 1 GPU offers, because that's just the only algorithm that will work unless min GPU equals num GPUs, because then you can be guaranteed that it's the same offer as the same size of the machine. But that's not going to give you much accuracy, because I'd say maybe 30 to 40% of machines on Vast have their configuration set that way. All right, so the first thing we do is, hey, were there any offers rented last cycle? If there were, let's carry those offers over. Let's carry those rented flags over, and it only carries the flags over of the offers that are currently rented and are not rentable. So basically, we will only carry over offers that are in a current rentable state, not unrentable state. So if in the last state something was rented and in the current state it is rentable, we know not to carry that over. But we discovered something recently about fragmentation and about how Vast will tell us that something isn't rentable when it should be rentable, and it was hurting our algorithm. So we had to add a little sanity check at the end to account for that. But let's keep going. So first, let's just see if we have offers to carry over. We do. Now let's check to see what's the last price, what's the current price. If the difference is between 0.05, we can't tell an exact price, because Vast, when republishing the data, they combine all of your inet and storage into the final price. So as long as your price hasn't shifted a point, half a penny, then we freeze it, meaning we carry over the last rented state of that price. So some hosts like to rent their price after being rented. we maintain your price from the moment you're rented. So if a host does that, we carry over its initial rented price. So they can raise their price as much as they want or change their price as much as they want. We maintain accuracy to the actual price at the time that offer was rented. Okay? So that's what we do. So now that we've carried over the last rented offer states into the current ones, we see if the diff between, so if we went from a 4 GPU server, 2 GPUs rented to 4 GPUs rented, we need to see what that difference is. Do we have any offers at that diff size that isn't currently flagged rented? If we do, let's flag that as rented. Let's add that to our new rented offer list. So something we just introduced to the application is every rental cycle, we will actually show not just utilization, but in the past 6 hours, these are the actual offers that were rented. This is everything that's rented, this is everything that's vacant, but this is everything that just was rented. So if you want to see, like in the last 15 minutes, this is what was rented in the past 15 minutes, and these were the prices. But my point is, the way that we calculate that, you'd never be able to ask a database to do that with 24,000 offers per sample every 2.5 minutes. You have to do, we have to capture those rented offers, and we actually store them in a new rented offers database. Okay? So let's go back to our rented offer analyzer. So that's basically where we account for increases in utilization. We find the offer of the size and we mark it rented. And in the decrease, if for some reason our initial rule because of fragmentation, if any GPUs were carried over, this is our little sanity check here that corrects that for us. So that's our rented offer algorithm and how that works. Sorry, I should have displayed that before. And now let's get into the summary analyzer. So at this point, we have all of our rented offers in memory from last sample and now current sample. And we actually now save the new rented offers and offers themselves because now we're done modifying that data. And the data that we're using for the analysis is in memory. So we can start persisting while we're doing other work. That's how we're able to do everything in 2.5 minutes. So the very first thing we do is we start analyzing the listing contexts. We analyze the GPU utilization, regional GPU utilization, machine deltas, market correlations for all of those all rented offers between all the different ranges, and then we just wait for those to complete. Okay, so that's essentially how our ETL runs. Why don't I just quickly show everybody what these different tables look like. So for GPU utilization, this is what a summary table looks like. So basically for every type of machine, every type of offer, for every size, we calculate for machines for 8x5080s. That is the util for 5080s. That's the util for, so we have util GPU name. So that's the utilization for 5080s. Utilization GPU name num is the utilization for 8x5080s. We show the number of offers rented, number vacant. We show 90th median and 10th percentage prices. We show what's basically what percentage of 5080s is the 8x and what's the percentage of all GPUs is an 8x5080. So needless to say, this is what GPU util looks like, and we create a summary at every sample period for every market. And a market is GPU and numbered GPUs. So we create one of these every sample period. And we do the same thing for regional. So regional GPU util has the, I'll show you that from a live. That's just my development box. Quickly show you. So regional GPU util here. So here we have that same utilization, but now with a region associated with each. Okay? So let me just quickly close that, close that, close that. In terms of the correlations, so remember how I said we have rent. So for RTX 5080 1 by CPU cores between 17 to 24, these are the 10th, 50th, and 90th prices at that sample for that specific hardware metric for an unverified 5080 1 by. So basically we do for every range of metrics that we evaluate for every market, at every sample period, we know exactly what arbiters were rented and how much they were rented for. Okay? So that's essentially most of the tables. In terms of the machine metric, machine performance, machine correlations, very similar. So we basically say, hey, for this machine, which is a 5080 1 by, here is its performance against all other machines like it in each of these categories at the 10th, 50th, and 90th percentile, and we actually capture the diffs as well. So that's essentially all of our tables. That's how we do everything that we mentioned here. It's because someone's saying I look a lot older. So I've got a question here is, how's the data looked with all of the CPU mining for Juno in Burgess? Well, unfortunately, we don't know exactly what's being captured, and we do that on purpose. So the only machines where I could capture what's actually running would be with a listing agent client, and we're not supposed to be looking inside the container, so I unfortunately can't do that in Bruges. Hey, how's it going? Eric's, hey, everyone's here, cool. And I know I look older just because of my big beard. I'm trying to look more civilized. Anyways, I'm not sure if anyone has any other questions, but we will be posting this, and we were going to have another video on Wednesday, which is going to be how the listing agent client works end to end and how to use it. And then the one on Saturday is going to be how things like PCI bandwidth, version, and lanes can impact DL perf and your score and your auto sort position. But we're going to have a bunch of these coming down the pipe. Looking forward to getting more engaged with you all, and I thank you for your time today. See you later.